Greetings everyone, and in this screencast I'm going to give you a walkthrough of some sample controller code, and hopefully you've listened to the overview screencast already so you kind of have prepared for what's going to happen. Let me talk about what I want to highlight in this particular presentation. I'm going to build upon the code we developed in the models module. So that's our simplistic little warehouse, product, tags, stock items, data model, and I'm going to make some changes because of the API, the REST API, REST-ish API that we're implementing. In the entities, the one thing I'm going to do is I'm going to change the field that was called ID. I'm going to change that to be called primary key to make it explicit what that field is a database field. And then I'm going to add in another ID, product ID, tag ID, etc., which is the natural ID, the domain ID for those entities. And you'll see when we're actually trying to retrieve things from the using the REST API that we have to supply an ID to actually retrieve a particular object. We don't want to use the primary key for that. That could change, you know, based upon when you fiddle around with backend databases. So we don't want to be revealing the actual primary key to our clients. We want to have a natural ID for that. And similarly, we don't want to use natural IDs as primary keys for, you know, basic database reasons. The other thing that we're going to be doing in the model classes is adding validation annotations, which is ways that we can declaratively specify constraints on valid entities, and you'll see how we can use code to do that testing. It's kind of a nice little trick, or not a trick, but a feature of Play, and these, I think it's JSR 303, Java Bean, and annotation kind of things. In the routes file, we're going to, in this implementation, you'll see that we're going to add in calls to implement a kind of a REST-ish API for at least a couple of our entities. I don't do all 5 classes. I just do a couple of them so you can see, and then I'll leave it as an exercise to you guys to fill it out. In the controllers class, we're going to add a controller for each of our entities, or at least for 2 of our entities. And then for all the routes that we define, we'll add an action method, and then in each action method we're going to do some validation so you can see how that works, and then we'll add a test case. Okay, and again I want to shout out to Play for Java, where I got the warehouse data model idea. The controller code that you're going to see here is pretty significantly different from what you would see in the book, because in the book they actually are using views, and I'm deliberately not using views in this presentation to kind of simplify things and enable you to think about controllers in isolation from the view, which I think is kind of nice. But anyway, good book. It's manning early access, so there's some, you know, typos and stuff in it right now, but you may want to look at it. Okay, so when I say this REST-ish API, what I'm going to say is there's a get with a slash, you know, the name of the entity type, which will return all of the products. There's a get products with the actual ID of the product ID that we're interested in, and that will return information about that specific product. There's a post slash products, where we provide in the body of the post request the attributes that will be used to create a new product. And then we have a delete products with an ID that enables you to delete the product. And that's the create, read, update, delete CRUD interface. Very standard, and you know, shows you kind of the essentials of how you do things. Okay, so look ma, no view. What's cool about this, in my humble opinion, having implemented myself, is that what you're seeing is we've already built a model last week. Now we're going to build a controller, and I'm going to tell you basically almost nothing about views in this lecture. There's one little class called the form class that it's going to turn out we're going to look at that one, but you won't even really think of it as a view necessarily. It's just part of our validation framework. And what's cool about this is it means that you can test your models, you can test your controllers, you can test your business logic without worrying at all about what the user interface looks like. That's very powerful. That's called separation of concerns. That's a very important software engineering technique for controlling complexity. Okay, so that's the good news about doing things this way. The bad news is that once you actually go out and try to implement your view, you're probably going to have to make some modifications to your API to support the view. For example, views normally depend upon Browsers don't have a delete method. They usually don't emit the delete HTTP operation, so we're going to fiddle around with our API a little bit. And that's okay. You know, that's really fine. It's kind of a minor change. Okay, now the third thing, which I think is really very important, I want to emphasize this from the outset, is that in this class, for pedagogical purposes, I'm showing you how to build a model without any reference to a controller or a view. Then I'm showing you how to use a controller built on top of the model without any reference to a view. And then finally, next week, we're going to start worrying about views. That's awesome in terms of building up your knowledge in an incremental way and enabling you to only kind of have to grow one little concept at a time. It's not the way you actually do web application development, okay? Web application development actually goes the exact opposite way. The way you really should be thinking about it is you develop your presentation, your view, as the very first thing. Okay, you have to get that right first. That's something the customer is going to interact with. It defines the user experience. There's wireframing packages. There's all this stuff out there that enables you to do mock-ups of your presentation. Make sure that's right. And then from that, you generally drive what the controller looks like, even what your data model looks like. Okay, so I just want that to be clear so that you don't think that this is the way we do web application development. We sit there and we create the data model first. Okay, in general, that's not an efficient, at least, way to go about it. You should really start at the view at the other end. Okay, but for learning, I think this is a pretty good way to go. All right, so let's now jump in and I'm just going to give you a quick overview of the code. And I think the right way to do it, I'll start with my models, okay, because that's what you saw before. And we'll reveal the import statements. I don't think many of them changed. And what you can see here is, for example, that used to be ID last week. I'm calling it primary key this week to make it clear that's the database model. And now we've introduced this new variable called product ID, which is the natural ID for this class. Everything else is pretty much the same. Our constructor is now going to require a product ID. When we create it, we got this finder. Oh, and then I also made a toString method, which will be used when we actually try to print out an instance or return an instance of this product to the browser. We'll return it in a string that looks like that. And that'll make our testing a little bit easier. And of course, it's always nice to define a toString. I don't think I modified the stock item at all, and the tag method I did analogous kinds of things. So now the ID is called the primary key field. I've got this tag ID field, which I didn't have before. That was called name before, but we're going to call it tag ID now, just to kind of for a little bit of consistency. And we're going to have a validate method associated with this entity. Okay, now this is important. There's I missed some things here. Right. Okay, so let me step back a bit. I forgot about this. Okay, what I also added to the product class is validation annotations. Okay, so this is kind of an awesome thing. Last week we only had this @ID field, and we had this many-to-many and one-to-many, and that was all for defining our data model. This week we're adding some other annotations, which are annotations just like the other ones, but they're completely different. Okay, these are annotations that are used to establish whether or not you are, or what's required for an instance of this entity to be a valid one. And what we're saying here is we're saying that the product ID field has to be filled with something, with some kind of string. It can't be null. Similarly, we're saying that a valid product entity has to have a non-null name field. Okay. We're not providing any annotations or validation constraints for the description field. So I guess description can be anything. Okay? So that's another key part of this, is that we are now we have annotations, and this is kind of a confusing thing, but you got to understand that annotations in these entity classes can serve two completely different purposes. One is to define the data model and the object relational mapping, which is what we covered last week, and that's the @entity, @ID, and these many-to-many things. And then we're going to have this whole second set of annotations that are going to appear, and they're going to be all intermingled with these other ones, which specify the constraints or validation properties that have to be associated with the entity. And in fact, you could have validation annotations mixed in with the ORM validations. Okay, now going back to tag, what I want to note is that in addition to a annotation for which we're using to specify that this specific field has to be non-null, we can also, for any given entity class, we can write a method called validate. And you'll see this, I'll give you a reference to it because it can have a few different forms. I'm having the form where it returns a string. And this validate method can basically do anything it wants. In the case where it returns a string, if the validation process that you do in your code within this method, if it fails, you should return null. Excuse me, if it succeeds, you should return null. And if the validation process fails, you should return a string that indicates what the particular validation problem was. And there's other kinds of return values you can, other versions of this method that have a nicer interface for real purposes. But for now, we're just going to use this one because it illustrates the idea. And what you can see, the code here says, we're going to implement this crazy little constraint which says that a tag ID cannot be the string tag. Okay, just to kind of give you a sense for a validation, you can't, it's not really that easy to specify that kind of constraint using one of these annotation symbols. So we'll implement a method which will check to make sure that this specific value of this tag ID is correct. And this validation can go out and do anything. It can access the database. It can check across entities. So it's basically your general purpose code to do things, more complicated validations than are possible with these annotations, which are essentially going to just check simple properties of individual fields at a time. And that's really nice. It's a great way to do it, but that's generally not sufficient to do all the kinds of validation that you would want to make sure your data model is consistent and everything is correct. Okay, so now we've covered where validation occurs. You see we've got these annotations, and then we've got the possibility of defining an explicit validate method. All right, there's our models. If I just look at stock item, I think, yeah, you can see that I changed the ID to primary key, and I've added the stock item ID. Everything else is pretty much the same. Similarly in warehouse, I've got primary key, and then I've got a new field called warehouse ID. You can see I've got some annotations, the at required, but I haven't done anything else. Okay, so that's the changes at the model level. That brings you up to date with what happened last week, and I'll just put this out there so you can see. Here's one thing to notice is that when you want to add one of those validation annotations, it is an instance, an instance of the play.data.validation.constraints package. So that's what the import statement looks for that. Okay, next thing let's go to is let's look at the routes file. And here we have a routes file. I'm keeping this get of the top level to just go to controller's application index. That's the way it works in the hello world, default play application that you get when you say play new application. But now we have two sets, well, let me get this right, two sets of REST-ish APIs, one for products and one for tags. Okay, and we should have them for, of course, for stock items and warehouses as well. I'm going to leave that for you guys to fill out. But doing these two gives you the general sense. And I think it'll be a good exercise for you guys to go ahead and do the other two just so you can get your hands dirty a little bit. And the notion here is, of course, we have the get HTTP operation. If you pass it /products as your pattern, then it's going to go to this particular method in the controllers package, the index method in the product class of the controllers package. You can see here we can put variables, that's preceded by a colon, and then we can refer to that variable over on this side. This is using the Scala parameter syntax, so this is actually a Scala class definition, crazily enough. The syntax for that is a little different from Java, but you can just, it's pretty straightforward. Here's the way we define a new product using our REST API, and we'll have to add into the body of this post request the attributes necessary for creating a new product, and then delete. We'll have the product ID here, and that'll be passed in as this parameter. Okay. Now note, if you try to compile your play application and you're referring to a action method in the routes file and it doesn't exist someplace, you're going to get an error because this actually compiles into a Scala class definition, and then it's going to refer to these things, and it better be there, which is pretty cool, as I've said before. Okay, so that's that. The next step is, you can see in our controllers package, let me just do this so you don't see. Okay, so there it's a little bit easier to see. In our controllers package, we have this application, which is what, I haven't even changed this from the default one. Obviously, you'd get rid of this, when you're really making something, good. But I'm trying to kind of impact on this hello world application as little as possible. So I left it around, and what I did is I just simply created a second class within the controllers package, which is going to take care of all the action methods for the product entity. And then similarly, I created another class to take care of all the routings and the action methods for the tag entity. So anyway, we'll look at the product one here. And what you can see is, here's the action method for index. Basically what this does is goes out to the database. Now you notice that we have a product in the controllers class, but we also have a product in the models class. Okay, so that's nice in some ways, and it's not nice in other ways, because now we have to qualify when we're referring to the entity product within this particular class. So that's a little bit bogus. Not really bogus, but it's just, you have to distinguish between, you have to disambiguate the two. So there's our import statements. So we're going to create a list of entity models, entity products, and we're just going to basically invoke the entity product class, call it invoke its find method, get the list of all of these product instances, and then if it's the case that there weren't any products defined yet, we'll return the string no products as the result. Otherwise, we'll return the toString of these products, and the return type is going to be OK, that's 200. And that is a definition of a view in some extremely, lame definition of a view. But so we are actually returning something into the browser. You could go to localhost:9000 and type this in, and we'd actually see this stuff. But it's nothing really that interesting. What we'll do next week is we'll replace basically this part with our view definition. Okay, so to a certain extent we can just leave everything else the same and just replace what goes inside the OK with a more sophisticated call, and now we've got some crazy beautiful Twitter Bootstrap user interface. Here's the details. So we're going to be passed in the ID, and basically we'll do this little string here where we'll look up in our database find the entity whose product ID is what we've been passed, and then that's going to be our entity product. And then if we didn't find it, we'll return the not found HTTP code. I think that's like 404. Otherwise, we'll return OK with the product. Pretty straightforward, I hope you think. The new product is where we create it. This is going to be the result of the post method. Now here's where things are a little tricky and kind of cool. It took me a while to figure out how this worked, and when I figured it out, I thought, those play people, they are pretty clever. Okay, I like the way I like their thinking. Now other people, you see comments in Stack Overflow where they're like very confused by this, and it is a little confusing, but let me try to explain to you what's going on here. So basically, we are passing in the post method. You'll see in the test classes, we're going to pass in the body a bunch of parameters and values which provide all of the fields necessary to create a product instance. Okay? Which is great, but there are constraints. Like for example, we want to make sure that when we create a new product, there is a product ID associated with it. Of course, it'll get a primary key we could put in the database, but we want to make sure that field, product ID, actually has a value for it. Okay, and if we look at our our model, we have this required validation notation. Okay, but the question is, how do we actually invoke that annotation and actually find out that things are required, and how do we control that? We need that to be under the control of the programmer. Okay, and in the controller, that's where you want to do validation, because you really don't want to depend upon as I said before, you don't want you to depend upon the user always using your particular client interface, because they can always create some crazy HTTP request using some other program and get around all the validation that you might be putting on the client side. So here's what we're going to do. We're going to use this form class and pass it an instance of our entity. Okay, and that's going to create so that's going to create, if you just look at the syntax, we're saying create a form instance, which is actually part of the view. It's a user interface component, but don't worry about that aspect of it right now. Right now, we're thinking about this as a validation approach. We'll create this form instance, which is this crazy kind of object, and we're going to bind from all of the parameters in the request. We're going to bind those parameters to this object. So we're going to get this thing called product form. It's not an instance of our product entity, okay, but it's something that has all of the data and the state that would be in our product entity if we were to make one, okay, but it's not one yet, okay. So we've got this product form, and that has a has errors method associated with it, which will go in, and because when we instantiate this thing, we give it our entity class, it knows about all those validation annotations, which is quite ingenious in my mind. Okay, so we've got this thing which isn't really an entity instance, but has all of the properties that the associated entity instance would have. We invoke this has errors method. If that returns true, then something went wrong. And what I'm saying here is I know that from my validations that product ID and name is required, and so if we got has errors, it can only be because one of those things went wrong. Now there are ways to attach a message to the validation annotation and do this in a slightly more elegant way, and I'll leave that for you guys to discover on your own. But this is one way to do it. We have to spread the information around a little bit, but it's too bad. Anyway, if this returns false, so there's no errors, then we know, hey, this is great. This form contains the data necessary to create a valid instance of an entity. So then what we do is we take this form instance and we invoke get on it, and lo and behold, it returns an entity instance called product, which is valid because it didn't have any errors. So we can save that out to the database and we can return OK. Okay, so there's two things we can return. Bad request if the variables passed in this HTTP request were not sufficient to create a valid product, or we can return OK and the toString of this entity instance that we've created and saved out to the database. So I think that's really cool. I think this validation is really nice. The code here is pretty mellowed out. We're attaching basically all of our validation stuff to the product. It's all encapsulated within this entity class, the product. There's some of the annotations there, that's some validation, and then we could have our validation method, that would be the other part, and all we do is call this has errors method on this form instance that we create out of our entity, and it all works. Okay, hopefully that makes sense. If not, just rewind, listen to this about 14 times, and I think you'll get it. Or maybe you won't get it and you'll have to actually implement some code, but eventually it'll seep in, and then you'll go, those play guys, pretty awesome. Okay. Here's what the delete thing looks like, and essentially the way I'm implementing delete is that if you pass it a product ID where it can actually find it, then we'll invoke delete. Otherwise, we'll return OK. So what's interesting about it, you can pass the delete, you can call delete with a product ID that isn't even a valid product, and it will return OK. So you can't return an error here. The notion being that what this delete operation ensures is that if there were a product with that product ID, it's not there anymore. Okay. There's various ways you could implement this. This is just this, kind of the semantics that I'm attaching to that one. All right, so that's how our product.java works. I'm going to go to the tag method. The tag method is implemented almost exactly the same way. You can kind of stare at this, pause and stare at the code. And what you'll see is basically everything is just about exactly the same, except for this has errors where the error message is that we cannot create a tag whose name is actually tag. Okay, and that is a reference to the validate method. Okay, so I did have this required, and I don't. I could have had the error. I should have made the error message. Oh, you know, we have to have a required tag ID. But the main thing is, we want to make sure that we and this is kind of a, you know, just a pedagogical validation. This doesn't have too much meaning in practice, but we're going to check to make sure that no one implements a tag whose name is tag, and that's something that's you know, easier to do here. Okay, so we've got, just to review, we've got our routing file where we specify the action message associated with the various HTTP requests involving products and tags. We've got a controller for products. There's our action methods for products. Okay, and then we've got our controller for tags. There's our action methods for tags. Final thing, let's test it. Okay, so I'll go up to the top of this file. You can see there's a whole lot of imports. Sorry about that, but I like listing all of the import statements so you can see exactly where things come from. One thing I don't like about the Play folks is that their sample code always has wildcarded imports. Makes it really difficult to figure out where the heck things are coming from. I much prefer, for educational purposes, fully qualified import statements. So there they are, and of course you have an IDE, so you can always get rid of them if you don't want to look at them. So here's our controller test, and the controller test looks a lot like the model test at the top. We have a fake application, we have these before and after methods, okay? And here's how we're going to do it. There's a standard approach. We're going to get a result by invoking the call action method with the reverse router, okay? So this is to say, we invoke this, and you can just kind of parse this code. It's going to be controllers.routes.ref, and then you give your controller class name and the action method that you want. And what this basically does is returns the actual HTTP request that would end up invoking this particular action method. So you call that, and then what we're going to do is check when we have an empty database. We call getProduct. What we get is the string no products back, okay, which is what we want. And then what we do is we want to test the get product with a valid product ID. So first we have to create a product. So we get the product ID, create the product, we put it in the database, then we call this index, and then we make sure that the product ID is in the content that's returned from this request. Okay. Just so you guys know, if I go to here and I invoke test, you can already see it in there, but we'll run the test and we'll see, oh great, all our tests pass. So that kind of proves that all of this code actually works. Then we can call test get with I'm sorry, we just did that. Okay, so let's move on here. Now we're going to call it with some crazy product ID that doesn't exist in the database, and we'll make sure we get this not found result code. Now let me show you how to do a post, which is to create a new method. And the way you do that is you first start out by creating a map of strings where the key is going to be the attribute that you want to set, and then the value is the value of that attribute. So we're going to create a product whose product ID is product-02. Here's the name of it. Here's the description of it. Then we do this thing. We create a fake request. We call this form URL encoded body to take our product ID map and put it into the request. And then we just we call a different version of call action where the first method, it's the 2arg version. The first argument is the reverse routed action method, and the second thing is this request object that we've just created, this fake request object. And then everything's the same, and now we check to make sure that we've actually successfully created that product. Okay. And here's an example where we're going to invoke it without any form data. So we created a new request, but we don't invoke this with form URL encoded body part. So there's no actual body to this request. And then we get this bad request back, which indicates that we ran our validation and we couldn't find a product ID in our form object that we created. So we get this bad request back. Finally, we're going to test the delete call. So we're going to delete our product ID product01, and then we'll call it again, or then we'll check to make sure that that we'll call the details method, and we'll make sure that it's not found, and then we'll call delete again on a not found object, and we'll discover that that's okay too. Okay? Going on to the test tag controller, pretty much exactly the same thing going on here. The only thing that's a little different when we want to test an invalid tag is that we're going to create a fake request, and we're going to say our tag ID is tag. And remember, that's the thing that's not valid. Okay, so that's the only tag you can't create. And if we go back here, we can see then we put that into our URL encoded body, and then we call the action, and we get this bad request back indicating that you can't create a tag whose name is tag. Okay, and then the delete works all the same way. So there you go, the whirlwind introduction to designing controllers in Play. Take a look at this code. I want you to type it in. You'll have to watch this screencast very slowly to get access to all the code, but hopefully I've shown you all of it. And I think when you've done typing this all in, as I had to type it all in myself, hopefully that will give you a good sense for how Play works.